Welcome back, everybody. This is Mr. Navarrete, and today I'll be going over organic reactions number 1. So with that, let's get started. For this homework, we have to write the products for the following reactions. So looking at my first one, I have a hydrocarbon with oxygen. I know I'm going to have a combustion, so I know that my products are going to be CO2 plus H2O. Now I know it's not balanced, but you can balance it on your own. For number 2, we have an alkene, and we're going to have a halide. So we're going to be adding those fluorines into our double bond. So it should look something like this. We're going to get rid of that double bond and add fluorines on both carbons. Now it doesn't matter if you added them on top or like I did, because we can rotate that molecule and we'd end up at the same one. For number 3, we have another hydrocarbon and oxygen again. So we know that our products are going to be carbon dioxide and water again, just another combustion. For our next one, we're going to have an alkane, in this case butane, and we're going to be adding bromine to it. Now this is going to be a substitution, meaning that one of the hydrogens will be substituted by one of the bromines, and one of the bromines in that molecule will be substituted by a hydrogen, just a swap. So our products are going to be our alkyl halide and HBr. For our next one, we have our triple bond there. It's going to be an alkyne, and we're going to be adding a halogen to it. So we know that one chlorine is going to go to our carbon 1, and the other one is going to go to carbon 2. So our product would be 1,2-dichloroethene. Now, where you put the chlorines is up to you. Again, just not going to be too picky on it, as long as you're able to properly name it. So in this case, if you wrote it as across, it would be trans, and if you wrote them on the same side, then it would be cis. For our next one, we have our carboxylic acid, and we have our alcohol here. For this reaction, we know that the oxygen in that alcohol group is going to bond to that carbon in there, kicking off that OH. So our first bond would look something like this. We are creating an ester. So just to color code which ones came from where. My double bonded oxygen came from our carboxylic acid here, and my rest of the ester came from our alcohol there. For this reaction, not only are we going to be making our ester, but we'd also be making water. For our next one, we're going to be adding our halogens to our double bond. So each one is going to gain a bromine. One will go there, the other one will go there. So our product would just look something like this. Again, it doesn't really matter where you put the bromine, either on the bottom or on the top, since we can freely rotate that molecule. For 8, we have an alkane, we have our halogen. So this one is going to be a substitution, just like the one that we did before. So our product would just be our methyl chloride and HCl. For our next one, we have a hydrolysis reaction, and one way I like to kind of picture it is writing the water as HOH. That way we can kind of look at it as an addition, like with our halogens. One of the hydrogens will go there. The OH group would go to that other carbon there. So our product would just be our alcohol, propanol. For our next reaction, I'm going to again draw the water as HOH. That way we can kind of see what's going on, as my OH group will go and form a bond with my carbon there, kicking that other chain off. My first product would be propanoic acid, and my other product would be my alcohol, in this case ethanol. 11, similar to one that we did before, again writing it as HOH, just so that I can see that addition. One hydrogen to one carbon and my OH to the other carbon, creating that alcohol, ethanol again. For our next one, it might look like it's trying to trick you because of all of the double bonds and our oxygen there, but just remember, it's going to be a hydrocarbon. Anytime you see that hydrocarbon and oxygen, it's a combustion reaction. So we know that our products are going to have to be carbon dioxide and water. And you can, again, balance this one on your own. For our next one, we have our carboxylic acid. We have our alcohol. We know that this alcohol is going to form a bond with that carbon there, kicking off that other OH. And our first product would be our ester and also water. 14 is just 13, but with a longer chain of carbons. Same steps, my alcohol is going to form a bond with that carbon there, kicking off our other OH. So my first product is going to be my ester and water. For 15, we have our aldehyde, and we're adding oxygen. And if the oxygen does throw you off, remember, it's still going to be a hydrocarbon. So it's still going to be a combustion. Our products would be CO2 and H2O. And again, just balance it on your own. Our next one, we have our alkane, and we also have our bromine. This is going to be a substitution reaction. We're going to be substituting one of the hydrogens in our alkane with a bromine, and one of the bromines here with a hydrogen. So my products would be CaH17Br and HBr. I'm only writing it like this so I don't have to draw out all of the carbons and the hydrogens. Next one, we do have our benzene ring. It's just a hydrocarbon with oxygen, so combustion reactions to be the first thought. Products are going to be CO2 and H2O. For our next one, we have our triple bond. We have our halogen, so this is going to be an addition. One fluorine is going to go to that carbon, the other one will go to that other one. So my product would be 1,2-difluoroethene. Now again, remember, depends on where you added those fluorines. It can be cis or trans. Not going to be too picky as long as you're able to name that compound. For our next one, we have our carboxylic acid. We have our alcohol. I feel like we've done something like this before already. That OH will form a bond there. My oxygen there is going to form a bond with that carbon, kicking off the OH, creating or joining those two chains together to form our ester. So my first product would be our ester here, and our other product is going to just be water. For our next one, we have two amino acids. Here we have glycine, and on this side we have alanine. So just like how we did in class, we know that our nitrogen will form a bond with our carbon there. We're going to kick off that OH, and we're basically going to be joining these two amino acids together. So we'd be making glycolalanine and water as well. And that's going to be it. If you have any questions, don't be afraid to ask. We're here to help. But other than that, stay safe, and I'll see y'all next time.